And so here we are with the agenda. So, healthy soils and sustainable vegetation, that's kind of the foundation. And we're going to look at the 5 fundamentals. This is something we put together. It's basically a process developed to help ensure the best possible outcomes for each project site. And then throughout, I'll sprinkle in some local projects and some cost savings ideas. So this is on a macro level, sustainable vegetation can save money, particularly through like ET covers. They're going to be cheaper than geosynthetic covers. They're more durable. They don't degrade over time. Also, through reducing erosion, you don't have to maintain ditches with sediment on roadside ditches, and we're just keeping sediment out of our fisheries. So, what is sustainable vegetation? Basically, it's a vegetation that once established can grow and flourish through nutrient cycling. To obtain this, we need a healthy soil as that foundation. And on the next slide, this is just kind of a breakdown of what goes into a healthy topsoil. A big portion of it's going to be your minerals, your sand, silt, and clay, but also a lot of water, a lot of air. And for that, you need void spaces, you need proper soil structure, and then your organic material and your biotic material. Unfortunately, so many of the sites around here, this is what we're left to work with. The Ouray horizons, they've been scraped off. We're left with the subsoil. Even worse, we might have toxic mine wastes, acid rock drainage. This is what we want to try to get to. We want to rebuild that O&A horizon, rebuild that topsoil, so we can get that nutrient cycling going. Which, so much of that happens underneath the ground. Biological activity is critical to nutrient cycling, and we'll touch on that in some future slides. So jumping into the 5 fundamentals. You want to start with creating your optimal soil conditions, kind of like as Brent mentioned. We want to pick the right plant species, select the right erosion control materials, and ensure that they're installed properly, and inspection and maintenance. So going into the first one, it all starts with your soil testing. This gives us a measure of soil fertility, also provides a basis for amendments. You might need to adjust the pH or other issues with the soil. Helps ensure the appropriate plant species selection. And just so you know, there's many ways to get free soil testing. I know there's a lot of nonprofits in attendance here today, so if you have any questions on how to do that, get with me over lunch or this afternoon. Not going to go into this, but at a minimum, these are the things you should test for. And here's some sample soil report. This is actually the Dolores, Colorado area. So number 1 here is the topsoil. Number 2 is the fill dirt. Again, not going to go into each of these different parameters, but kind of the big 3. You're going to have organic matter, pH, and salinity. On this one, organic matter is actually pretty good. pH and salinity are a little high, but nothing we couldn't work with. So, and then tab 1 more. So kind of the takeaway from this slide is an eye chart, but for each characteristic or parameter that we're testing for, there's an optimal range. You get below that, you're going to have deficient soils. You get above that, you can actually have potentially toxic soils. Here's just some pictures that put off the web. These are project sites around this area. As you can see, there's no organic material, and these sites are in pretty bad shape. Contrast this with here's some other sites. The one on the left there is the Silver Bell Mine. It's near Ophir, Colorado 145. Crossfire was the contractor. They scraped off their topsoil and they stored off to the side. And there's that Monsanto photo from Brent's presentation. They got that 8.8 acre, 30-foot tall stockpile on the front. So both these sites are doing the right thing. However, there's a lot of research and a lot of literature out there which indicates that over time, plus or minus 6 months, you're going to start to lose that biological activity. You don't have the water in the air to sustain their life, and that really affects the soil structure as well. So numerous and very important roles of these microorganisms. They're basically the glue that binds the soil together, holds it together through aggregation. They recycle the nutrients, of course, but they also convert organic material into mineralized nutrients. By maintaining that soil structure, you get those void spaces for air and water during a precipitation event. That's going to increase infiltration rates into the soil, which is going to delay runoff, which is important for erosion control. And kind of this last quote here is from Jerry Hatfield. The USDA does research in Ames, Iowa. We build soil through biological activity, not by physical or chemical manipulation. Those are certainly important. Physical manipulation, if you have compacted soils, you're going to want to rip those or disc those. Chemical manipulation, if you've got a pH is out of whack, you're going to need to address that in some way. But ultimately, you get a productive soil through through biological activity. There's a lot of ways to do that. A big way to achieve that is through biotic soil amendments. This is a good way to address these kind of low organic dead soils. It's a good cost-effective alternative to bringing in compost, topsoil, or other expensive amendments, sources of organic material. A good biotic soil media is going to contain those ingredients there, and it's basically everything you need in a productive soil except for sand, silt, and clay. Application rates for, there's a variety of products out there. It's all going to be based upon your soil testing. Like so many things goes back to your soil testing. So, and then I guess tap a couple times. So here's just kind of like a side-by-side comparison. 2 truckloads or tank loads of biotic soil media is equivalent in mass of organic material to 36 truckloads of topsoil. So that's kind of your value proposition when you're looking at the cost of importing in soil, versus adding an amendment. If you tap one more time, it should be noted that on a toxic soil, a tailings pile, which for 70 years nothing's grown on it, you're still not going to be able to amend that with biotic soil media. You're going to have to bring in some sort of barrier material. So this next project, looking at the Matterhorn mine, this is a project which is in the early design phase. Running some numbers for topsoil at $35 a cubic yard, versus fill dirt at $21 a cubic yard. You can amend that fill dirt and really get to the same place, but saving $30,000 per acre. Even it could save even more money if you don't have to import any material at all. If that soil testing indicates that, hey, with some amendments, you can actually work with what you already have on site. Just bring the biotic media, bring the bugs, bring the endomycorrhizae, bring the organic material, you might be able to get to the same result at a significant cost savings. And then moving on, we want to pick the right plant species. Again, a lot of variables. We can't really go into all these. Big ones are, where's the project, and the site characteristics out here. 8,000 feet versus 12,000 feet. You're going to look at different species. Also, the aspect: is it south facing? Colorado sun's going to blast it all summer long. It's north facing. It's going to be shaded up. Fortunately, there's a lot of good resources out there. I would recommend starting with a local seed supplier. They know the area, they know what works. Other resources are listed there as well. In the next slide, this is courtesy of Bill Coughlin, the Western Streamworks. This is what was used at the Silverville line. This is a project I worked on with the we supplied the liner, we provided the seed. So a great variety of different species there. So you want to have that species diversity. And on the next slide, I shared this with my technical director. He's an agronomist, and he's like, hey, this looks like a great mix, but there aren't any shrubs in here, and maybe they should consider some of those. So having worked on the site, I knew that there was a geosynthetic clay liner. This is an instance where you want to avoid woody species, so the roots can penetrate or compromise the integrity of that liner. So you kind of have to think about the whole site when you're looking at your seed mix. And then something else to consider, the engineer sent me over this picture. This is what the vegetation looks like next to that big nasty tailings pile which nothing's growing on. So these are the species which are native to the area, and this is kind of your expectations. Hey, after a successful reclamation project, this is what we can expect to grow in this area. And then we want to select the right erosion control material. It's going to take time for these seeds to grow in, so we want to make sure we don't have too much erosion in the interim. This was kind of a schematic of kind of the mechanism of raindrop erosion. You have detachment, transport, deposition. This next slide is what it looks like in our rivers, and the one after that is what it looks like on our job sites. And then the next slide, product selection. How do I know which product is best for my site? Best place to start is going to be with the Russell equation. We're not going to go into this, just we're limited on time, but this is going to, in general, the output's going to be pounds per acre per year of expected soil loss. Each product is going to have a cover factor. The rest of these factors are going to be specific to that site. Rainfall, soil, slopes, lengths, that's all fixed. So how do we get the seed factors for all your different products, which you can select out there? It's through lab testing. You can kind of see the raindrops of the kinetic energy, just very destructive testing. And on the next slide, this is just kind of a summary of a variety of different products. The highlighted ones maybe consider like a good, better, best option. It's like a good product is going to be 75% effective, a better product 95% effective, and your best product 99% effective at controlling erosion. There's even a good product can have up to 83,000 pounds per acre per year of soil loss. On the next slide, just some other things I wanted to share with the group here, things to consider when you're looking at selecting the right erosion control product. A lot of these native seeds, they take a long time to germinate and to fill in. So, whereas a good product with 75% erosion control effectiveness might be good, that functional longevity of 3 to 6 months, 3 months typical, might not be sufficient for your site. You might have to go with a 12-month or 18-month functional longevity to protect that seed, retain that moisture over time. This is just kind of a graphic representation of the good, better, best vegetative solutions on the bottom. Above that, you get your reinforced vegetation, and then above that, hard armory, like your riprap, your concrete line channels. On the y-axis, it's an increase in velocities, increasing shear stresses, increasing slope angles. And as you might expect, as you move up that chart too, costs are going to increase. And here's a Silver Bell site. As I was leaving the site, the rain was coming in. I'm on Colorado 145, the San Miguel River between me and the site of this picture. Thinking back at what I know now, other than the GCL, what's the most expensive part of this design is probably all that riprap. So on the next slide, maybe they could have considered, or maybe consider on a future project, and maybe save some money. Look at a turf reinforced mattress, which can give you triple the protection, erosion control, and shear strength as just natural vegetation. This next slide, this is kind of what it looks like when it's going in. This is a river project. I wouldn't recommend this product for constant flows, but if you're going to have like ephemeral or intermittent flows, this would be a good product to consider. And this is what it looks like coming in. So it looks pretty good. It looks a heck of a lot better than riprap too. They lined that whole bin with riprap. And on the next slide, just want to not only does it look better, it's going to be cheaper too. So compared to riprap, concrete lining, there's just a couple of different turf reinforcement mats that are going to be infilled with your seed mix and your mulch mix hydraulically applied. So you can see, these products can save a bit of money, also blend in better with the environment. So just something to consider when you're, looking at, placing a bunch of riprap in a rock line channel, for example. And then, so we've kind of looked at the seed mix and the products and all that, but when the rubber hits the ground, we want to make sure that it's installed properly. As engineers in this group and as owners, specify this to your contractors. Don't always assume they're going to use the best management practices. Get that in writing and specifications as well as plans and drawings. So there are any questions out there on the job site. Manufacturers have installation guidelines to make sure that those are available. And there's also online tools and other calculators available for ratios of seed mixes and erosion control products, etc. So lots of tools out there to use for your construction. And then moving on to inspection and maintenance. This is kind of the last step. We want to have someone there as a certified professional, or at least is very familiar with the products and the goal and the owner's goal of the site to ensure the contractors is doing everything according to the plans and specifications and drawings, and also getting the right material quantities and not skimping on materials or cutting corners like on the fence. That one with the wattle just didn't quite go all the way. You want to be there to ensure everything's done properly. And then something else to keep in mind, out here, site's covered in snow, you can't get up there every 3 to 6 months, but make provisions for periodic inspections to make sure you're getting the grow in and the erosion control that you're looking for on these sites. And then if there's like a really bad weather event, maybe not a bad idea to send someone out there to take a look and see how the site's holding up. So just kind of wanted to leave you with one last thought. It's expensive to do a project and have to go back and do it again. So here's an example. This is a car in Tinsdale, Ireland. Went off into the water, so they bring a truck to pull it out. So they're slowly lifting it up. And on the next slide, you can see catastrophe strikes, and the truck just rolls over and falls into the water. So to rectify this, they bring in a bigger truck, pull out the smaller truck, and then I assume they're going to fish out the car next. But this just kind of resonates with me as far as you can save your client a lot of money by getting it right the first time, by doing your soil testing, getting the right seed mix, doing the right erosion control material, and just making sure so you can install it properly. So with that, I think we're on time. So if there's any questions?
Yeah, have you documented water quality improvements just from vegetating a waste rock pile? Or is it just for erosion control?
Repeat the question. Repeat the question.
The question was, have we demonstrated water quality improvements through sustainable vegetation? I think the biggest one would probably be for like an ET cover where you're limiting the infiltration. That's going to be more of a groundwater issue than a surface water issue. But if you got that storage layer and you're basically keeping water from migrating into the tailings or the waste rock and leaching material out, you can prevent that migration without using a liner. I'm not sure of any instances where we can demonstrate that we improve surface water, but certainly groundwater.
Yeah, you caught my attention with one of the slides you were talking about the seed mix to put in.
Yeah.
And you said, should we put in shrubs? And no, we don't want to because of the barrier. Well, of course, given enough time, the shrubs and trees will come in. What happens when the roots penetrate the barrier?
That's a really good question. And working for a company previously that sold geosynthetic liners, that was always a question like, how is this thing going to last? So you've got to have like 500 years, so about 750 years, that liner is pretty much compromised. So it's a perpetual maintenance type situation. You're going to have to mow that site, essentially, is the answer to that, which is why now I'm happy to be on the good side and promoting sustainable green solutions. So if you could design that ET cap right, which isn't always going to work. Some areas, if you've got 6 feet of snow and then the rain on snow event, it might overwhelm an ET cap, but in a lot of areas, an ET cap is going to perform very well. But yeah, with the synthetic cover, you're going to be looking at perpetual maintenance.
Question.
Yes.
What are your synthetic covers made of? Are we talking plastic or?
Generally, the most common one is going to be an HDPE, high density polyethylene liner. Geosynthetic clay liner actually has a sodium bentonite barrier in between some polypropylene geotextiles with an HDPE generally laminated on top of that. It's like a 4-layer component system, but generally HDPE and the geotextiles are going to be polypropylene.
Stockpiling soil to store the organic matter in the soil. Is there a protocol for stockpiling soil to preserve that, or is it always going to happen?
Can you repeat the question?
Yeah, the question was, how can you, you stockpile your soil, how can you, prevent the loss of the biological activity? I was reading one paper where they referenced, you could till it periodically. That's probably not as effective either. And it's basically a function of depth. So the further that 30-foot pile, after about 2 feet, 5 feet, 10 feet, everything below 10 feet is going to be dead. So you could have a thinner lift, and that would work better to maintain that biological activity. The organic matter should still remain, but you're just losing the biological activity. Unfortunately, a lot of these sites, you're space limited, so you can't. That was it. 30 feet high, almost 9 acres. They probably didn't have 50 acres to do a lift that was smaller. All right. Well, thank you.